All right, we'll begin the exam review. We'll start with a question from Chapter 1. Now, in Chapter 1, we introduced all of the types of transformations. We talked about vertical and horizontal translation first, then we did vertical and horizontal stretch, and then we talked about vertical and horizontal stretch. Did I say stretch or reflection? Stretch. Okay, so we did stretches, reflections, and translations. This was a type of question where I asked you to come up with the equation of g at x. Now, you could just manipulate the mapping rule and work backwards. Once you have your mapping rule, you could have find a, b, h, and k, and then write your equation. But I showed you a 6-step process. And the first thing we did was we asked ourselves if there was any reflections. So once again, in this question, this represents the old function, and this guy right here represents the new function. Old, original, new, transformed. My job is to come up with the equation of the transformed function. Now, is it reflected in the x-axis? So here's what it would look like if it was reflected in the x-axis. There's the x-axis. If the red curve was reflected in the x-axis, it would look like this, or something like this. So the point -4, 4 would become -4, -4. 0, 0 would remain 0, 0, and 4, 4 would become 4, -4. All of the y values would get multiplied by -1. Would you say that the red curve looks like this? Is it a V that opens downward? No, this is a V that opens upward. So how would I answer the question if I asked you, is it reflected in the x-axis? Yes or no? So there's no reflection in x-axis. Please, Vinny. What does that tell me about my A value? Positive or negative? Go ahead, someone say it. It would be positive. If there was a reflection in the x-axis, A would be a what? Negative. And where can you find that information? On the whiteboard, yes? And I'll even go one step further here. I'm going to label some points on the original curve. I'll call this point A, this point B, and this point C. Now it looks like cold. All right. I'll go A prime, B prime, and C prime. These are the image points. So this point, -4, 4, became this point, -8, 10. This point, 0, 0, became this point, -7, 2. And C became C prime. Now, is it reflected in the y-axis? Here's what you would do. What would happen if I reflected it in the y-axis? What would happen to this point, A, -4, 4? It would go to C, it would go to this side. The x value would get multiplied. So my A prime would go over here. B prime wouldn't change, 0, 0. If you multiply a 0 by a -1, it's still 0. And this point right here, C, 4, 4, would become -4, 4. Now look at, does my new curve go C prime, B prime, A prime? No, it's still A prime, B prime, C prime. So once again, that would mean that there is no reflection in the y-axis. So this particular question, there was no reflections at all. What does it mean? Which parameter does it affect? A, B, H, or K? When we're talking about reflection in the y-axis. It's the B value. If there is a reflection in the y-axis, B is a negative. If there is no reflection in the y-axis, B is a positive. That's what that means. B is greater than 0. The next move is I want to find the vertical stretch factor. And I do it in this particular order because I go for A, B, H, and K. All right? For the vertical stretch factor, I have to compare, I'm looking like the range. I'm looking at the number of units. I'm going to compare A prime to B prime. How many units is that? From 2 up to 10. It's 8, Gav. Thanks. I'm going to compare that with the old or the original. Now know this, that if I compare A to B on the new, I have to compare it with A to B on the old. How many units is that? From 0, that's where B is, up to 4. It's 4 units. When you're calculating your vertical stretch factor, you would go 8, it's the new, divided by the old, 4. What's that equal? What's 8 divided by 4? It's 2. Yeah? Now, the vertical stretch factor, that means the following. That means that A could be a plus or a minus 2. In order to figure out which one to use, you have to look at this information. It was not reflected in the x-axis. It means that my A value is a positive, so that means I should choose positive 2. Is that all right? Step 3. I want to go after the parameter B. So in order to figure out B, I need to know the horizontal stretch factor. What's the relationship between B and the horizontal stretch factor? They're what? Reciprocals. Great. Awesome. Okay. I am going to compare A prime to C prime. A prime is at an x value of -8. C prime is at an x value of -6. How many units wide is that new graph? From -8 to -6, how many blocks? It's 2. I'm going to compare A to C on the old. This one goes from -4 over to +4. That would be 8 units wide. Now, what's the move? Do I go 8 divided by 2 or 2 divided by 8? Well, think about what you did in the last scenario. Did you go 8 divided by 4 or 4 divided by 8? I went 8 over 4. It's the new over the old. So it's 2 over 8. So I'm going to write 2 divided by 8. Now, 2 divided by 8 is not 4, folks. What would that reduce to? 2/8 is 1/4. That would mean that B, if my horizontal stretch factor is 1/4, what could B equal? Plus or minus 4. And which one will I check on? Or which one is correct? If you look at this, no reflection in the y-axis, B has to be a what? Positive. So I should choose +4. Is everyone okay with that? Awesome. Now, note this, like, you don't have to go from A prime to C prime. I could have went from A prime to B prime. That's only 1 unit wide. But if I compare A prime to B prime on the new, I have to compare A to B. So from A to B, it's only 4 units wide. I'd go 1 over 4. I'd still get 1/4 for a horizontal stretch factor. Next thing I'm going to do is I'm going to find the horizontal translation. You okay if I just abbreviate that HT? I want to pick a point on the original where the x value is 0. So I'm going to go with point B. What did that become on the new curve? What's B prime? I'm 7 units to the left and 2 units up. As a point, I would write that right there as -7, +2. With me? Now, realistically, what should I do to that 0 in order to get a -7? The mapping rule tells me that I would have to take that 0, multiply it by 1 over b, add my h value, and it would spit out a -7. The reason I pick a point where x is 0 is because it really doesn't matter what my b value is. I can just isolate the translation. Okay? But I'll fill this in. If I went 1/4 times 0, and I add h, it should work out to -7. All you're trying to do here is solve for h. What's a quarter of 0? What's 1/4 times 0? It's 0 plus h. Well, 0 plus h is h. What's my h value equal? -7. H is equal to -7. It's really unnecessary to show all this work. This is only good, or this is helpful, if you picked like point A, okay, and compared it to A prime. Watch if I pick point A, -4, comma 4. What does it become on the new curve? What's A prime? -8 comma what? Wicket. Now let's look at these. If I multiply that by 1 over b, what's 1 over 4 times -1/4? Anyone know what that is? That'd be -4 over 4, or -1 plus h equals -8. What would you do here to solve for h? What would you do with this -1? Add 1 to both sides and you'd get h equals -7. Okay? And it would work for point C as well. H is -7. What's the next thing I need to do? What's step 5? I have the vertical stretch factor and the vertical reflection. I have the horizontal stretch factor and the horizontal reflection and my A and B values. I have the horizontal translation, which is H. What else am I missing? Not the mapping rule. What's the last parameter? A, B, H, and K. I need the vertical translation. To get the vertical translation of the VT, I'm going to do the same thing. I'll try and find a point on the original where y is 0. So I can use this, 0, 0, and -7, 2 again. Point B is 0, 0. It became B prime, -7, 2. Now, when I was looking for the h value, I focused on the x coordinates. If I'm looking for the k value, I need to focus on the y coordinates. Think of your mapping rule. All right? I should really multiply this right here by my a value. So it'd be a times 0 plus k, and that should equal 2. Anyone know what my a value is from above? What did we say a was from step 2? Yeah. So if I go 2 times 0, and then I add k, I should get 2 for an answer. What's 2 times 0? 0 plus k equals 2. K equals 2. Okay, it's kind of unnecessary to do all this if I have a point where y is 0. because I know that doesn't matter what A is, if I multiply it by 0, I get 0. What do I add to this? What do I add to a 0 to get a 2? I'd have to add 2. So my K value is 2. And from there, step 6 is to write the equation. Now remember, the equation, it's not the mapping rule. I want my equation like so. Y equals A times F, B times X minus H, close the brackets twice, plus K. Your A value was in step 2. Your B value was in step 3. Your H value is in step 4. And your K value, your K value is step 5. So here's what I would write for the equation of that red curve. What will I fill in for A? What did you write down? 2. This F is for the original function because the equation that I'm naming here or creating here is a transformation of that original f of x curve. What do I fill in here? The 1/4 or the 4? It's the B value. The 4. Awesome. X minus, what's my H value? -7. What would happen to those two negatives? Become a positive. Awesome. And what's the K value? 2. My final answer would look like this. Now you could write G at X equals Y equals, it's all good. Close the brackets twice, plus 2. Now that is not the only way to do that question. Some people can literally just look and make the mapping rule. They would take their original points. A, that was equal to -4, 4. B, that was 0, 0. And C, that was 4, 4. And compare them to their image points. This was -8, 10. B prime was -7, 2. And C prime is -6, 10. Okay. This point's helpful. This kind of isolates the H and K. I can see that my H value is -7, and I can see that my K value is 2. All right, so I know my mapping rule would look like this. X, Y becomes 1 over B times X plus H, and A times Y plus K. If I fill in a -7, so instead of adding -7, I'll just put -7. And A times Y plus 2. Think about what you would have to do to this point to work back here, or this way. What would you have to do to this to get this? Well, I like to work backwards. Okay? What would be the opposite of subtracting 7? Add 7. If I added 7 to this, what would I get? A -1. What would I have to do to this -4 in order to make it into a -1? Think multiplication. -4 times what would equal -1? It'd be a quarter. This right here would have to be a 4. Now you can check it. -4 times 1/4. That would give me -1. -1 minus 7, -8. It'll work here too. A quarter times 0 is 0. Minus 7 is -7. And it would work for this point. What's a quarter of 4? What's 1/4 times 4? 1 minus 7, -6. Do the same thing for this. What would be the opposite of adding 2? Subtract 2. What's 10 minus 2? 8. What would I have to do to the 4 to get an 8? Think multiplication. 4 times what is 8? 2. And now I have A, B, H, and K. Look at the A would go there, the B would go there, the H, it would say X minus -7, and then the K would go here. Get the same answer either way. So this is a little more obscure. It's a little more manipulating the numbers yourself, mental math, where this is like a 6-step process. Do I care which way you do it? Absolutely not. What I'm looking for is this thing here in the box. I want the right answer. That's what you should want too. Okay, so that was kind of like one of the big questions from chapter 1, along with, you know, what are the transformations, reading a paragraph and picking out A, B, H, and K, making the equation, making a mapping rule, transforming some points. This was also from chapter 1. So if you flip to the next example, where it says find the inverse, these were the steps. Okay, step 1 says to replace f of x with y. So here's what I would do with that equation. I would change f of x to a y. So in the next line, it would read y equals the square root of x plus 3. Now I move on to step 2. It says switch the x's and y's. So that means everywhere there's a y, write x. And everywhere there's an x, write a y. Go with that? So step 1 and 2 are really just a joke. They're just, you know what I mean? Anyone can do that. And if it comes in the form y equals, then you don't even have to do step 1. You're moving on to step 2. You just switch the x's and y's. This is where the work comes in. I got to solve for y. I got to get the y by itself. So think about how you could get rid of the square root sign, and then how you could get rid of a plus 3. Start with the square root. How do I get rid of that? Square both sides. Whatever you do to the left, you would do to the right. Radical y plus 3 times radical y plus, so some people would do this. They would multiply this side by itself, and they would multiply this side by itself. And then what would you do to get rid of the plus 3? Subtract 3 from both sides, and you would have x squared minus 3 equals y, or y equals x squared minus 3. You with me on that? It's an equal sign. I can write it left to right or right to left. You can read it. It's the same thing both ways. Now, step 4 says replace y with f inverse x. That's how you read this. That's the notation for the inverse. It says if it is a function. How do you know if that's a function? Well, do you remember what this curve would look like? This is what we focused on in chapter 2. It's the square root curve. And it would have this shape. An endpoint here and an arrow there. Does that pass the horizontal line test? Because if this passes a horizontal line test, I know its inverse is a function. And the answer to that question is yes. Okay? If I stop anywhere, these blue, the blue and the red, the horizontal line and the function itself touch at one spot only. If they touched at multiple spots, it wouldn't pass the horizontal line test, and I wouldn't be able to do step 4. I would just leave it here and leave this as a relation. But I can do step 4, which says to replace y with f inverse x. That's my final answer. Cool? One more question, one more example to go through, and then you're free and clear to work on the sheets. And then we'll redo this stuff. We'll practice chapter 7 and 8 when we return on Monday. This comes from chapter 2. Okay, not only did we focus on square root functions and graphing them and picking out their transformations and making mapping rules and transforming points and drawing pictures, but we also focused on square root equations or radical equations. And in order to solve this, these were the steps. Step 1, we isolate the radical. Step 2, we square both sides. Step 3, we solve for the unknown, in this case, x. And step 4, we're going to test our answers. So step number 1, when it says to isolate the radical, that means to get the radical, the square root in this case, by itself. Is there anything, like is there a times 2 there? No, if there was, I would maybe divide both sides by 2. If there was a plus 3 outside the radical, I'd subtract 3 from both sides. So step 1's already done for me. Step 2, square both sides. I encourage you in this line to write it like so. Take the radical x plus 8 and multiply it by itself. But also take the right-hand side, x plus 6, and multiply it by itself. Common mistake is people think that x plus 6 squared is just x squared plus 36. It's not. Okay? What does this equal on the left if I multiply radical x plus 8 by radical x plus 8? With me? What do I get over here? I do get an x squared. I've got a 6x, another 6x, and a 36. So I do get an x squared and a 36. But if I just square that and square that, I'm missing out on these 12 x's that need to be there. How can I solve for x? What do I do with that? Set it equal to 0. What did I do with the x and the 8? I subtract x and I subtract 8, or I move the positive x from the left to the right and the positive 8 from the left to the right, and they would both become negatives. Group your like terms. 36 minus 8 would be 28. 12x minus 1x is 11x. What do I do from there? How do I solve for x when I have x squareds and x's, 3 terms? It's quadratic. I could use the quadratic equation. Or I think it's easiest to factor this as a simple trinomial, where I would look for 2 numbers that add to give 11, and the same 2 numbers have to multiply to give 28. Here's what I like to do. What multiplies to give 28? 1 times 28, 2 times 14, and 4 times 7. I know that both of the numbers have to have the same sign. They're either both positive or both negative because they multiply to give you a positive. I know they both have to be positive because they're adding to give me a positive. If they added to give a negative, both numbers would be a negative. If they multiplied to give a negative, you'd have 1 positive and 1 negative. All right, what are the numbers? Does that work for both? 4 plus 7? Yes. 4 times 7? Yes. What do I do here? 2 brackets. X plus 4 and x plus 7. And the only way you can multiply those 2 factors together and get an answer of 0 is if one of them actually equals 0. I don't know which one it is, so I set both of them equal to 0. Solving this one, I'd get x equals -4, and solving this one, I'd get x equals -7. So I've solved. I've got two solutions now, two potential solutions. How do I test them? I go back to the original. What did the original say? Radical x plus 8 equals x plus 6. So if I test x equals -4, I'm going to replace the x's with a -4 and check to see if the left-hand and right-hand sides are equal. What's -4 plus 8? It's 4. What's -4 plus 6? What is the principal square root of 4? It's 2. Only the positive answers. That's what it means here. So what would that say about x equals -4? It is a solution or it is not? It is a solution because the left and right-hand side are equal. What am I going to do in this situation? I'm going to fill a -7 in for the x's. And when I solve this, -7 plus 8 is 1, and -7 plus 6 is -1. What is the principal square root of 1? It's 1. Does 1 equal -1? No. That means x equals -7 is not a solution. Or what's the $50 word for not a solution? It's extraneous. That's right. X equals -7 is an extraneous solution or is not a solution. That's it. That's all for today.